Hello, welcome to ANS Solver. This is the sixth question of the paper. So, throughout this question, the use of calculator is not permitted. So, we have a complex number, okay, with the modulus 1, which means basically the distance, and the argument 1 over 3 pi. And it's denoted by W. Now, we need to express W in the x plus IY form. Okay, so what is the modulus? The modulus, the formula for the modulus, okay, you need to know is the square root of the real part the whole square plus the imaginary part the whole square, correct? Here if you see in our form the real part is x, so I can write this as x square plus my imaginary part is y, so I can write this as y square. And now I know this modulus is 1, correct? So I can simply say that x square plus y square is equal to 1 square, where I'll get my x square plus y square equals to 1. So this is one equation. Now what I need to do simply is I can say now I have the argument, correct? My argument is, let's say, something like this. Okay, it's a triangle. I'll make a better triangle. Just give me 1 second. So make a straight line first here, then get it down. Yeah. So let's say this is my right angle triangle. My argument here is, let's say, theta. Okay. So I know the imaginary part is always the vertical axis. So I have y here, I have x here. Okay. So I can say that theta is given by tan theta equals to the opposite over adjacent. So y over x. Got it? Now I know my theta is 1 over 3 pi. Okay. So now that's basically, tan 1 over 3 pi. So in degrees, I'll get tan 60. Correct? So I'll get that as root 3 equals to y over x. Correct? Because tan, I know my theta is basically 1 over 3 pi. Correct? So I can say that my y is equal to root 3 x. Okay? So now I can simply say that x square plus y square equals to 1. Now I can say my y is equal to root 3x. So I can write this as x square plus root 3x the whole square equals to 1, which can basically be written as x square plus, I know root 3x the whole square is simply 3x square, which is equal to 1. So this is 4x square equal to 1, which gives me my x square equals to 1 by 4, which gives me my x as 1 over 2. Plus minus, but it's normally plus because x is the length. Okay. So now what I need is, I know my x. So my y will simply be root 3. I can write here. I know my y is equal to root 3 into 1 over 2 now. So I know my y is root 3 by 2. So I can basically write my x plus iy as 1 over 2, okay, plus root 3 by 2i, which is the final answer of W. Got it? Now, the complex number 1 plus 2i is denoted by u. The complex number v is such that the mod of v is equal to the 2 into the mod of u, and the argument v, okay, and is equal to the argument u plus 1 over 3 pi. So let's focus on u first. U I know, okay, is simply 1 plus 2i. Correct? This is what I know. I know the mod of u, which I can simply calculate. I told you in the first part also, the mod of u is basically the square root of the real square plus the imaginary square, which gives me root 5. So now let's say I want to plot u with the red pencil. Okay. So I can say the coordinates, okay, are simply 1 comma 2, because 1 in the real part, I have my real here, I have my imaginary here. Correct? So I have 1 comma 2 in the the coordinates of u. So I have 1 here and I have 2 here, which says my center lies somewhere here. Okay, and now I know the mod. Mod basically means from the origin, or yeah, the modulus of u is simply something like this. Correct. And I know this mod here is root 5, the distance. And I know this is simply u. So now if you see, let's say I take my blue pen. Okay, I need my v. I know my v is the argument of u plus 1 over 3 pi. Okay, so the argument of u we can simply calculate, which is the angle here, which is simply given by, let's say this is my triangle here, correct? This is my argument, the vertical line is the imaginary part, 2, 1. So theta, so I simply do tan inverse of 2 over 1, which is tan inverse of 2, which, while calculating on the calci, or yeah, I can simply get 1.107. You don't need to calculate this because, they haven't asked you to use the calci. So now, whatever argument you get here, okay, you should take 1 over 3 pi plus to get the argument of v. That means the argument plus 1 over 3 pi, okay, gives me the argument of v, okay, which I can say is somewhere here. And let's say if this was, I know my u, the modulus of u was root 5, we know the modulus of v, or the distance of v, is 2 root 5, correct? So I can simply say the blue line will be much larger, double larger than the u line, okay? So I can simply say this is v, okay? And I can state that the angle in between is 1 over 3 pi, because simply the difference between argument of v and argument of u is simply 1 over 3 pi. So yeah, you don't need to calculate this. This I just did for your understanding, because as you can see here, the calculator is not permitted. So you just, need to get an approx. Okay, I just did it for your understanding. Okay, yeah. Now, the third part. Explain why v can be expressed as 2uw. So we already know that the modulus of v is equal to 2 into the modulus of u. Now see, if I multiply 1 to this, it will still stay the same. And now if you see the modulus of w, okay, is simply 1, which I have in my part 1, which is simply 1. Okay, so I can say v can be expressed, okay, can be expressed as the mod as 2uw, because there's another reason why you need to know. Here I know the argument of v equals to the argument of u plus 1 over 3 pi. So I can simply say the argument of v minus the argument of u equals to 1 over 3 pi. Now if you see, my 1 over 3 pi is the argument of w. So I can simply say this here is simply the argument of w. So I can simply say, because of, now you know how to write it. I can say because mod of w equals to 1, okay, and arg is 1 over 3 pi. Okay, so understood the logic? Now we need to find v, giving my answer in a plus iv form, sorry. So now I know my v can be expressed as 2 into u into w. So my v equals to 2 into, I know my u from above, 1 plus 2i. So I can simply put 1 plus 2i here, and my w I know from above, which we calculated here, 1 over 2 plus root 3 by 2i. 1 plus root 3i over 2. Correct? I can write it like this. I can write this. I can take the 2 common here because the denominator is the same. Now what I can do is I can cancel the 2 here. Correct? To simply get 1 plus 2i into 1 plus root 3i. So I can write this basically as 1 into 1 plus root 3i plus 2i into 1 plus root 3i. So I can simply write this as 1 plus root 3i plus 2i plus 2 root 3i square. So I can write this basically as 1 plus root 3i plus 2i. I know I square is basically minus 1. So I can write this as minus 2 root 3, which can basically be written as 1 minus 2 root 3 in the real part plus 2 plus root 3. Okay, and I can take I in the common part. Okay, so this is what I can say my answer. So I can say this is basically my A and this is my B. Okay.